Welcome to the final week of our class. This week, we'll be learning about how to graph quadratic functions. First, we need to understand what a quadratic equation is. A quadratic equation is an equation with a variable x in the form of ax squared plus bx plus c, most commonly, where a, b, and c can be any number except a cannot be 0. If a was 0, for any number that we put in for x, that first term, the ax squared, would turn up as 0, leaving the equation to be linear instead of quadratic. Before we start graphing, there are a few concepts we need to understand. First is the standard form of a quadratic function, which is ax squared plus bx plus c. The vertex form, which is a times x minus h squared plus k. And factored or intercept form, which is a times x minus p times x minus q. We also need to know the effect of a being positive or negative. If a is positive, then it means the parabola will open up and the vertex is a minimum, meaning it has a lowest point. If it's negative, then that means the parabola opens downward and has a maximum, or a highest point. We also need to know negative b over 2a. This finds the x-coordinate for the vertex or axis of symmetry. You can find negative b over 2a when the equation is in standard form. We also need to find the zeros or find the factors. Now we can do this by factoring like we did in the last video and setting it equal to 0, or setting the whole equation equal to 0 in the first place. Finally, we need to understand that parabolas are symmetrical. This will greatly help us plot the parabola. There are 4 main steps to plotting our parabola. First is to understand the direction of the parabola. This means to identify A and see if it's positive or negative. Next, we need to find the key points, which is the vertex and the zeros of the function. Then, we find one other point, or sometimes even 2 if needed. And finally, we plot a total of 5 points using the help of the axis of symmetry, and we draw a curve through the points that we've plotted. Let's start off with the parent function, or in other words, the most simple version of a function. Here we have y equals x squared. We can see that this is in standard form because a is 1, and technically the rest is 0x plus 0. First, we need to identify the direction of the parabola. Here we can see that a is positive 1, meaning that the parabola will open up and have a minimum point down here in the center. Next, we need to find the vertex and the zeros. To find the vertex, we need to find what negative b over 2a is equal to. Here, we can see that b is equal to 0 and a is equal to 1. So we can just plug that into negative b over 2a. So negative 0, which is just 0, over 2a is 2. So 0 over 2 is equal to 0. The value of negative b over 2a is the axis of symmetry for the parabola. So here we found 0, meaning that the axis of symmetry for the parabola is x is equal to 0. And also, we have found that the vertex of the parabola is at a point 0, comma y. Now, to find y, what we need to do is we need to plug in 0 back into the equation. So 0, y is equal to 0 squared. This means that y is equal to 0 because 0 times 0 is just 0. Now that we've found our direction of the parabola and also we found the vertex, we need to now find the zeros. So we can see that the vertex is already at the x-axis, meaning this is also a 0. So we can say that our 0 is also 0, comma 0. Now you can confirm this by setting the function equal to 0 and solve for x. So you get x squared is equal to 0. X is equal to the root of 0. This means that x is just equal to 0, confirming our original answer. Now what we want to do is we want to find 2 other points, and I'll explain why in a bit. First, what we're going to do is we're going to plug in simple numbers into the function. So the simplest numbers we know is probably 1 and 2 other than 0, because we already have that point. So we're going to plug in 1 and 2 into this function. So y is equal to 1 squared, which is just 1. And y is equal to 2 squared, which is equal to 4. Here, we're going to end up with 2 points. Since we plugged x for 1 point is going to be 1 comma, and our answer was 1, so 1 comma 1. And we also plugged in 2, meaning our x for another point is 2, and we got out 4, so the y is going to be 4. Now, we are going to plot the points we know. First, we have the vertex, which is at 0, 0. So we're going to place it here. We know the 0 is at the same place. So now we plot our other points, which is 1 comma 1. So 1 on the x-axis, 1 on the y. So here. And then the other point is 2 comma 4. So 2 on the x and 4 on the y up here. Now what we're going to do is we're going to use the axis of symmetry to find the other 2 points. Here we know that on whatever's symmetrical or whatever's on one side is symmetrical on the other, just flipped. So what we're going to do is we're going to use these points and then flip them. So you can see that this point is 1 away from the axis of symmetry, right? So if it's 1 away on the right, then if it's flipped, it's 1 away on the left on the other side. So here we're going to have the point -1, 1. Same thing with up here, the 2 comma 4, we're going to flip it. So this is 2 points away from the axis of symmetry, right? 1, 2. So we're going to do the same thing on the other side, 1, 2, meaning we'll have -2 comma 4. So our final points will actually, our total points will actually be 0 comma 0, 1 comma 1, 2 comma 4, -1 comma 1, and -2 comma 4. Finally, all we have to do is draw the parabola. What we're going to do is we're going to draw a line going through all the points, creating a minimum down here, and going back up. You end it with an arrow on both sides, meaning it's going to continue its way up on forever. Here we have -2x squared plus 10x minus 12. First, let's find the direction. We can see that A is negative, meaning it will open downwards. The parabola will look something like this. So we can write here that our direction is downward. Now what we need to do is find the vertex and the axis of symmetry using -b over 2a. So here we can see that -b would be -10 because b is 10. So -10 over 2a. So 2a, -2 times 2 is -4. This leaves us with 10 over 4, which simplifies to 5 over 2. This means our vertex is at a point at our 5 over 2, comma y, and our axis of symmetry, which I'll move down here, is at the line x is equal to 5 over 2. Now, to find the y of the vertex, what we're going to have to do is we're going to have to plug in 5 over 2 into this equation. So -2, 5 over 2 squared plus 10 times 5 over 2 minus 12. Now all we have to do is solve. So we have 5 over 2 squared, so 25 over 4 times minus 2, so that's 50 over 4, or minus 50 over 4, which is equal to 12.5, minus 12.5, I mean. So minus 12.5 plus 10 times 5 over 2, which is plus 25, minus 12. So you can see here that we have minus 12.5 minus 12, which is minus 24.5 plus 25. This means that this is equal to 0.5, or as a fraction, 1 over 2. This means that our y over here is going to be 1 over 2. meaning our vertex is at the point 5/2, comma 1/2. Next, we need to find the zeros. Here's where last week's lesson comes in handy. So what we're going to do is we're going to need to factor this to find its roots. So to do this, what we're going to do is we're going to factor by grouping since a is not equal to 1. So minus 2 times minus 12 is 24. And we need to find something that multiplies to 24 and adds up to b, so 10. So the first thing that comes in mind is 6 and 4. So we're going to group those numbers and pair them up with terms that have a greatest common factor. These are all even numbers, so they'll all have a greatest common factor. Doesn't matter what order you put it in. So we have negative 2x squared plus 6x, or let's do 4x on this side. 4x plus 6x minus 12. Oops. Now we're going to group them together. So these two and these two. And we're going to pull out a GCF on both of them. Minus 2x on this side. So what times minus 2x gives us minus 2x squared? That's just x. What times minus 2x gives us positive 4x? Just minus 2. And on this side, we can pull out a 6. What times 6 is equal to 6x? It's just x. What times 6 is equal to negative 12? Minus 2. You know it's right when these two match. And we're going to group these two GCFs together. So 2x minus 2x plus 6 and x minus 2. There you have it in factored form. You can see here that we can further simplify this because 2 and 6 have a common factor of 2. We're going to pull out a negative 2. What times negative 2 is equal to negative 2x? It's just times x. What times negative 2 is equal to positive 6? That's minus 3. And then we can just bring that down here. So this is our fully factored form. This is the furthest we can simplify. Now what we're going to do to find the zeros is we're going to set these parentheses, whatever these terms, and set it equal to 0. So we're going to have x minus 3 is equal to 0. And we're going to have x minus 2 is equal to 0. So to solve for x, all we do is bring 3 on the other side, or minus 3 on the other side, making it 3. And same thing on this side, we're going to bring minus 2 on the other side, making it 2. So these are two zeros. We already know that the zeros means that where it hits the x-axis, this means that the y is 0. So our point is going to be 3, 0, because x is equal to 3. And our other point is going to be 2, 0, because x is equal to 2. So our two zeros are 3, 0, and 2, 0. Finally, all we have to do is find one more point. What we're going to do is we're going to plug in a simple number into this equation, which is just a factored form or simplified form of this equation. So it yields the same answer. What we're going to do is we're going to plug in 1 because it's a simple number. So we're going to plug in 1 for x, so 1 minus 3 and 1 minus 2 all times 2. So 1 minus 3 is minus 2. 1 minus 2 is minus 1. And all times 2. And this equals 4. So our point is going to be 1, 4. This is going to be our final point, 1, 4. Now we're going to plot it. We're going to use our points that we know to plot the parabola. So first we have the point or the vertex at 5/2, 1/2. So 5/2 is 2.5. So 1, 2, 2.5 somewhere here, and it's half up. So it would be around here. This would be the vertex. Then we have our zeros, 3, 0 and 2, 0. So 2, 0 is right here, and 3, 0 is right here. Then we have our other points, which is 1, 4. So 1 over here and 4 down, so down here. and we have our axis of symmetry where the vertex is, which is always true. So if this point, this 1 comma 4 is 1.5 away from the axis of symmetry. Let me draw it for a second. So let's say our axis of symmetry is like this, and it's 1.5 away from the axis of symmetry over here. Then it's going to be 1.5 units away from the axis of symmetry on the right side. So 0.5, 1. It's going to be right here. Let me largen the dot right here. So we can see that this point is 4, 4, 4. So this will be our final point to finish off the 5 points needed. Finally, what we're going to do is we're going to draw the parabola. So it goes down, it comes back up, hits the vertex, and switches directions to go back down. And you draw the arrows because it's going to continue downward forever. Here's our next quadratic equation. -1 times x minus 1 squared minus 3. So first we have to choose or find the direction. The a is negative, so that means it's going to move downward. It's going to open up downward. As you can see, this equation is written in vertex form. This makes it very easy to identify the vertex. So to find the vertex, what we're going to have to do is we're going to have to set this parenthesis equal to 0. Or in other words, find out what makes this inside the parenthesis equal to 0. So you can see that if this is -1, to make this 0, we need to add 1. So that means that x should be 1. This means our x value for the point of the vertex is 1. And k right here, -3, is our y value. Meaning our vertex is at 1, -3. Next, what we need to do is find the zeros of this, or if it has any zeros. So what we're going to do is we could set this equal to 0, or we could expand this out using FOIL, like we learned in our past videos, and factor from there. For the sake of demonstration, I will expand this. So x minus 1 squared would be x squared minus 2x plus 1. And then it's multiplied by a negative, so all these signs change. So this would become minus, and then we get -3. So we end up with negative x squared plus 2x minus 4. We end up with negative x squared plus 2x minus 4. Now I'm going to let you guys know that this is non-factorable. So this means that we will have no zeros. 2 other points. What we're going to do is we're going to choose 2 easy numbers and we're going to plug them in as x. So let's use 2 and 3. So if we plug in 2 minus 1 squared, which is 1 squared, so and then you multiply by the negative, so that's -1 minus 3 is equal to -4. And the next one we're going to use is 3. So 3 minus 1 squared is 4. And the negative of that is -4. And then subtracted by 3 is 7. So -7. So our two other points are, we plugged in 2 and then we got out -4. And we plugged in 3 and got out -7. So 2, 4 and 3, 7 or -7 are our points. Now we're going to plot our points. So we have 1, -3. So 1, -3 here. Then again, we have no zeros because it does not touch the x-axis, because here's the vertex and it has a maximum since it's opening downwards. Our other points are 2, 4, so 2, 4, so 2, -4 down here, and 3, -7, so 3, -7 down here. Now what we're going to use is the axis of symmetry and just reflect the points. So if this 2 is 1 away from, if this point is 1 away from the axis of symmetry, it's going to be 1 away on the other side. And same thing with this point down here. So 1, 2. So that means that 1, 2. So our new points, or the new points that we added, are going to be, what do we add? Okay, we added 0, or yeah, 0, -4. And we also added -1, -7. So these are all our points that we have. And the last thing we need to do is we need to draw the parabola. So just like this. Put the arrows because it's continuing downwards forever. And there you have it. Our last equation is going to be in intercept form. So here we have x plus 2 times x plus 4. So we can see that there is no a value, or it doesn't look like it, but there is. It's just 1. So 1 is positive, meaning the direction is upward. So it'll open up. Since this is intercept form, we already have the zeros. So it's already in factored form. So all we have to do is find out what the zeros are by finding out what makes each parenthesis equal to 0. So what makes what plus 2 is equal to 0? Well, that's just -2. So -2, 0 is going to be one of our zeros. And what plus 4 is equal to 0? That's -4. So -4 is going to be our another 0. So these are our zeros. Next, we want to find our vertex. Now, to do this, it would be easier if we converted it into standard form. So that's exactly what we're going to do. We're going to FOIL this out like we learned in last week. So x times x is x squared. 2 times x is plus 2x. And x times 4 is plus 4x. So to combine, that's plus 6x. And we have 2 times 4, which is just plus 8. So now what we're going to do to find the vertex is -b over 2a. So -b would be -6. And since this has an imaginary 1, 2a would be 2. So this ends up being 3, meaning our x value for our vertex is -3. And our axis of symmetry is that x is equal to -3. To find the y value of our vertex, what we're going to have to do is plug in the x value, so -3, into the equation. So -3 plus 2 times -3 plus 4. So -3 plus 2 is -1, and -3 plus 4 is +1. So -1 times +1 is just -1. So this is our vertex, -3, -1. We only need to find one other point. So what we're going to do is we're going to just plug in a simple number that we haven't already plugged in. So let's do 0. If we plug in 0 here, we get 2. And if we plug in 0 here, we get 4. So that multiplied together is 8. So our other point is 0, 8. Finally, we're going to plot our points. So here we have our vertex at -3, -1. So -3, -1. It's around here. Then we have our zeros at -2 and -4. So -2 is right here, and -4 is right here. Then we have our other point at 0, 8, which is the y-intercept. So that's all the way up here. And by using the axis of symmetry, if this point is 3 away on the right side, the other point will be 3 away on the left. So 3 on the left would be right here, and then up at the top, so there. So we can deduce that our final points are, wait a second. Okay, our final points are, is just, what is this? 3, so -6, comma, 8. And these are all your points. Our last thing to do, like always, is finish the parabola. So we draw a line like this, curve, and add the arrows, and you're done. This is the final week of learning new topics. Congratulations. Next week, I'll be posting a review sheet for you to further your skills. I will also be posting a survey on Google Classroom. It would be extremely helpful if you completed it. It will take less than 5 minutes. If you have any questions about the content or worksheet, send me an email at newyork15@gmail.com or ask in the class stream. There are also other videos that I have linked if you need. Have a good week.